So what I was saying is that here's an application of the composite functions, right? Composite functions means you're taking one function and putting it inside of another function, right? And you could do that multiple times. I mean, you could take one function, put it inside of another function, and take that function and put it inside of another function. You could have an f of a g of a t, so you're sort of putting several functions into one. That's certainly possible. But let's just go back over the one that we stopped doing on yesterday, right? So I said, look, you have a formula for the circumference of a circle. It's 2 pi r. It's in that black box right there. You have a formula for the area of a circle. It's pi r squared. It's underlined right there. Is there a way that you can put them together so that you could actually figure out what the area of a circle is if somebody just gave it a circumference? Right? You don't really have to, first of all, figure out what the radius is, and then from the radius, put that back into the formula for the area. You should have a connection that takes you straight from the c, the circumference, to the area. And we worked it out to be this thing right here, the c squared over 4 pi. And I know I wrote this down wrong, so let me just correct my error right here, right? C over 4 pi works out to be c over 2 squared times 1 over pi. Right? The way I had it yesterday was wrong. So I've just erased that. I don't want anybody to write down what I just had there because that was wrong. The pi is actually part of the denominator. Okay, so we were about to, let me erase this as well. We were about to apply that to a circle that had a circumference of 8 pi. So, Quinn, to answer your question, no, I'm not saying that 8 squared is 16. It never was, it never will be. Okay? So 4 into that should give me 16, I believe. Might want to double check that. I've done such a bad job today that you probably want to double check that. Okay, so 64 over 4, I believe, is 16. And then one of the pi's cancels out, so left with 16 pi centimeters. And that, of course, would be area. So we're talking about 16 pi centimeters squared. Okay, folks, if I messed up anymore, please, you're welcome to point that out. Right? But that's what I'm getting now. 16 pi centimeters squared. It's area, remember, because they were talking about the area of the circle. All right, folks, tell me if I messed up anywhere else. Please help me out here. Help a teacher out. Did I do anything else wrong? No? Okay, thank you, Chrisania. Thank you for the endorsement there. So 16 pi squared finally is our answer, but it took us a couple of steps to get there, unfortunately. All right, I'm going to have to do some serious editing to this video. Thank you, Donna. Okay, all right, let's keep on. Let's do. I have one more question I'd like us to tackle, and then we're going to move on to adding and subtracting these functions, right? So what we've been doing is composing them, like putting one inside of another, but we're going to be adding and subtracting them later on. But let's just do this one last question here. So a spherical hailstone grows in a cloud. So spherical obviously means that it's a sphere, but it's getting bigger. The hailstone maintains a spherical shape, so it stays as a sphere, and its radius is increasing at the rate of 0.5 millimeters per minute. All right, so it's growing. And they give you the rate of growth of this function. So they're asking for a few things. What is the r? And r here refers to the radius with respect to time. Right? So that's what the first one is. That's what the RT is. Right? What's happening to the radius as time passes? What's happening to the volume as the radius gets bigger? And that's just simply an equation for volume when it relates to radius, which we'll get to in a minute. Determine the v of t and explain what it means. So let's see if we can put this all together now. What would be the r of t, right? I need a function that will generate the radius based on the amount of time, right? So as time, and that's what this thing says, that the radius is growing over time. It's growing at a rate of 0.5 millimeters per minute. So can you think of an equation that will make that work, right? What's the radius with respect to time? An equation. Give me an equation that will make that work. So when I put in the time, it spits out the radius, right? If the time was we're talking minutes here, 6 minutes, then I do something with that 6 and it turns out that the radius is going to be whatever that works out to be because of that formula. If the radius was 52, I put that into the formula. Thank you very much, Roma, 0.5t. Right? Just simply multiply those two things together. It's really that simple, right? If I know what the time is, then I just simply multiply it by 0.5 because every minute, that's what this thing says. Every minute, my radius goes up by half of a millimeter. So 0.5t. Now, the radius you're going to get from this is going to be in millimeters. Let's just be clear on that. You have to pay attention to the units here. The radius you're going to get from this is in millimeters. Okay, so that's the first function. How about a v of r, right? In other words, how does volume vary with radius, right? What's the connection between those two when we're talking about a sphere? Well, you'd have to remember, go back and think back at perfect Kelvin. You'd have to think back to what the formula is that relates volume with radius. And if you look at what Kevin just put in, he's absolutely right. It's 4/3 pi r cubed. Oh, no, you've gone too far ahead though. That's the v, that's not the v of r. What you've given us is the v. What I'm looking for the v of r formula, the volume that relates to radius. You've gone ahead and given us the answer for c, which we're not quite ready yet. So the volume related to radius, right, would be equal to the 4/3 or 4 pi r cubed divided by 3. 4/3 pi r cubed. Right? Hopefully everybody remembers that formula from, I don't know, grade 9 maybe, or grade 8. I don't know when you'd have learned that. Let me just put that in a little bit better. So this is the formula, right? That if I had the radius, this would give me the volume. It's 4/3 pi r cubed. Hopefully that rings a bell for most of you. Okay, or all of you, I should say. So now, and this is where Kelvin's answer does come in. What is the V of t? In other words, let's cut out the middleman, right? We have two functions here, but can I make them into one function that takes me straight from v to t? Okay, so he's got the answer there already. It's when you take the r and substitute that with what r is equal to. This function tells us what r is. It says that r is equal to 0.5t. So I can actually put that into this other function. So 4 times pi times, I'm going to put it as t over 2, right? No particular reason, but that's what I'm going to do. To the power of 3 over 3, right? T over 2 means the same thing as half of a t, right? 0.5 times something means you're dividing it by 2. So I just chose to put it as a fraction because I think that's going to make it easier for us in a minute. So have I lost anybody here? Please stop me, tell me if that step makes sense. If I isolate my r, which is already isolated from the first line, so this first line right here, the r is equal to 0.5t. So I can substitute in my second formula for r. If I plug in my r as being 0.5t, it gives me this third line that I've just come up with here. Shiabun is confused. Okay. What we're doing here, Shiabun, is we're composing the two functions. We are taking one function, just like when we're composing functions yesterday. Remember when we were doing this yesterday? And we took one function and put it inside of another function. It's essentially the same thing that we're doing right now. So one formula, the very first formula, which I'm going to, what am I going to do now? I'm going to circle it in green. This first formula here tells us what r is. Did that line make sense, Shiabon? That r is equal to 0. R, which is a function of time, is equal to half of t. Okay, good. So now we're going to take the r that's in the second function, the one I've just circled, and I'm pointing to it right now. See that r right there? Let's make a substitution. Let's put what we said in the green box into that red circle. Does that make sense? So wherever we see r, we're going to put in t over 2 or 0.5t, which is the same thing, by the way. So that's what the third line is saying. Okay, Shiba. Okay, great. And thanks for the question. I appreciate those questions. So the reason I use the fraction is because I really want to sort of make this a little bit simpler, a little bit more friendly by just using fractions. So I'm going to say, I don't know why I changed colors here. Let me go back to black. So I'm going to say 4 times pi times t over t to the power of 3 over 8. All right, that's cubing both the t and the 2. And I'm going to multiply all of that by 1 over 3. All right, so I just want to have, all fractions everywhere. Right? And why am I multiplying by 1 over 3? Because I'm dividing by 3. So another way of dividing by 3 is to multiply by the reciprocal of that, which is 1/3. Okay, so here we go. So in this format, I can see that the 4 and the 8 will reduce down. So I'll just do that. So that's 1 and that's 2. Okay, so what do I have left on top? What I have left on top is 1 times pi times t cubed over 6. So it's t cubed, or pi t cubed, I should say. Pi t cubed divided by 6. Let me just double check that because I've made so many mistakes today. 1 times pi times t to the power of 3 times 1, and then 1 times 2 times 3, which is 6. Okay? Is everybody good with that? Does that make sense? All right, let me check in with the room on that. Okay, great. So this is my v of t formula, right? Now, what does this formula actually mean, right? What is this formula actually relating here? Can anybody sort of break that down for me? What's the v of t formula really suggesting? Can anybody put that into their own words? What does a v of t formula really mean? Are you just reduced? Are you reducing it? I can't reduce that anymore, Lynette. I can't see how I can reduce that anymore. So I'm leaving that in exact form. Okay, how would I reduce that? Lynette, please go ahead. Yeah. I just multiplied out all the numerators. So it's 1 times pi times t cubed times 1. So this one here times that, and then the bottom will be 1 times 2 times 3. That's how I got the 6 on the bottom. Okay? Yeah. And the 4 and the 8 would have canceled down to 1 and 2. So just hopefully, does that make sense? Okay, great, perfect. Okay, so what is this function here? What is this v of t really supposed to do? Right? Volume in terms of time. Thank you, Hussein. Right? So now I can actually get the volume. If you tell me the time, how many minutes has passed, I can tell you the volume right away. Right? That's what this formula is doing. I don't have to first of all figure out the radius, then take that radius and put that radius into the volume function, because this is doing it in one step. There's a relationship between time and the radius, and there's a relationship between radius and volume. So that allows me to link these two together into one composite function. Okay, so that's what the v of t is. So what is the volume of the hailstone 1 hour after it begins to form? Okay, so what we're really asking for is the v of 60. Remember, this was in minutes. So we're talking about an hour. So I'm putting 60 in for the time. Okay, so that would be equal to, quite simply, pi times 60 cubed divided by 6. And that's where calculators come in. I have no idea what that number is. Let me see if I can do that in my calculator quickly. More 160 to the power of 3, 21600. All right, this is what I'm getting. So 216000 pi divided by 6. So that divided by 6 gives me 3600 is what I'm getting, pi. Okay, yes, Quinn, go ahead, please. This is, yes, question D. What's the volume of the hailstone 1 hour after it begins to form? Yes, that's what this is. Right, you're welcome. So it's 3000 pi, and the correct units for this, remember we were talking about volume here. So this would be, I think this was millimeters. Yes. So this would be millimeters cubed. All right, that's the volume. And yes, I should have a statement that says the volume of the whatever it is, the snowball. What is this? Hailstone. Okay, so the volume, I'll just shorten it. The volume would be, I'm putting it in exact form, 3600 pi millimeters cubed. Okay. All right, so that's where I'm going to end this stuff on composite functions, unless anybody has any questions. All right, I hope you can see 36, 36. Oh, yes, you're quite right. I'm missing a zero. What's wrong with me today? All right, let's do that. Thank you very much. And let's put those zeros in, which is what we had. And this should have been 3,600 here as well. Yeah, 36,000 rather. Thank you. Thank you. Thank you very much. Davina wants me to scroll up a bit. Yeah, don't forget that this is going to be on the video later on, but guys can scroll up anyway. There you go. You got something different, Donna? Whoa. Is it 3,600 pi or because I got 36? Yeah, it is 36,000 pi, which is what I think I changed it to just now. Yeah, 36,000 pi. Millimeters cubed. Okay. Yeah, thanks. If the function is defined as, and I told you yesterday that a function can be defined as just simply ordered pairs. If the function f of x is defined as 3, 5, so 3 is linked to 5, and 6 is linked to 2, and the g of x function is 3, 9, and 6, 5, determine the following. What is f of x plus g of x? Now, if I threw that out to you and said, let's add these two functions together. The function is given as two coordinates, right? Two ordered pairs for f and two ordered pairs for g. How would you do it? Could somebody tell me what they think those ordered pairs would be? Right? I'm just gonna ask you what you're thinking they might be. Right? Come on, let me hear what you got. Anybody? I'll take any answer you can give me. It might not be right. I mean, that's fine. I just want to hear what you think is going to happen when I add these two functions together. So one function is 3, 5. The other function is 6, 2. Sorry, no, that's wrong. One function is 3, 5 and 6, 2. The other function is 3, 9 and 6, 5. Any guesses as to what the result of adding those two might be? Nobody have a clue, a little inkling, a little thought about what they think it might give them? No? Well, I'm going to write it down for you. The first point, let me see if this is going to surprise anybody, would be 314. And the second point would be 6, 7. Oh, Roma had something there. And Donna was thinking 9, 7. Okay, Roma is, no, you're right, Roma, you're quite right. Does anybody think they can explain what I just did there? So, Chrysania, not quite. I know what you did, right? I know what you did, but what did I just do? No, Chrysania, it's not me. Okay, all right. Anyway, what do you think is happening here? You added the numbers. Yeah, I did add the what? What did I add though? Did I just like the second values? Yeah, I did. I had the y values. But the other thing you have to pay attention to is it's not just any y values. I first of all matched up the x values. So I didn't add the 5 with this 5 over here. I didn't add that. I look for when the x is matched. So there was a 3 with a 5 and a 3 with a 9. So when the x's match up, then I add the corresponding y's. Hopefully that makes sense, right? So since 3 was with 5 and 3 was with 9, then 3 now is going to be with 14. That's the sum with those 2 points. The 6 was with 2 and the 6 was with 5, so the 6 is now with 7. So you're looking for the x values to be the same, then you can sum the y values. Okay? So that should give you a clue as to how to do the difference then. How do you think the difference is going to work? Right? I want to take the f function and minus the g function. Can anybody suggest, now that I've explained the first one to you, can anybody suggest what the result of that might be? We're subtracting this time. Can you go over the first one again? I sure can, Hussein. I sure can. So look at the first function. It's 3, 5, and 6, 2. Okay? The second function is 3, 9, and 6, 5. So what you're going to do, Hussein, is try to find the x's that match up. Right? So the x's that match up are the 3 with the 5 and the 3 with the 9. The 3 doesn't change. The 3 is still going to be 3, but you take the y values and you sum them together. You see what I just did there? Okay, so that's why the 5 and the 9 get added together, and that's why the 2 and the 5 get added together, give me the 7. The x does not change. The same x value gives me 2 different y values. I just simply add the y values together. Okay, let's get to the second one. Look at the f of x minus g of x. Okay, so Brandon is thinking it's 3 minus 4 and 6 minus 3. So let's write down what that is. 3 minus 4. Let's just see if that makes sense. I'm taking f minus x. So it's going to be 5 minus 9, which is minus 4. Perfect. Again, the 3 still stays as 3. Now look at the 6's now. It was 6 and 2 with 6 and 5. So take the 2 and minus the 5. So you still have 6, but now you're going to have 2 minus 5, which is minus 3. So perfectly correct. Absolutely. All right, Shiobun thinks it's 0. No, it's not 0, right? The x does not change, right? You're not subtracting the x's, Shiobun, right? You're looking to get the match on the x's. But once you match the x's, then you look at their corresponding y's and you either add, subtract them as the case might be. And in this case, I was subtracting. Okay, how about the last one? Last one is just simply reversing the order in which I am subtracting. So why don't you give that one a shot? What are the coordinates that you would have if I were to subtract them the other way? What do you think, folks? Alexa thinks it's, and Chrisania also, by the way, thinks it's 3, 4, and 6, 3. Well, you're actually both right. And I'll tell you this, if you work out a subtraction one way and get your answer, if you subtract it the other way, you're going to get the same numbers but the opposite signs. So for instance, the first subtraction was minus 4, that became positive 4. The other subtraction was minus 3, that became positive 3. So you have the subtraction done one way, then to subtract it the other way. Remember that subtraction is not commutative, which means the order matters. So switching it around just simply changes the sign of the outcome. All right. Okay, now we're going to take it with the Jamboard in a bit, and that means I'm going to have to stop recording this. I'm just going to explain to you how this works, and we're going to do it on the Jamboard together. All right, this is referred to as a superpositioning principle. I am not giving you the function. I'm not giving you the actual equation for the function. All I'm giving you is the picture and asking you with the picture to either add them together, subtract them from each other, etc., etc. So this first one here that we're about to do, and I'm going to do the first few points with you, is I'm going to add f of x plus g of x, right? Let's say that f of x is the quadratic function as it says on top there, right? So in this case, it's the red line, right? It's this line right here is a quadratic, and the linear is the blue line. And I only want to go from minus 3 to 5 with my addition. So watch as I put the first 3 points in. What I'm going to do is kind of what we just did a while ago. At minus 3, remember, I'm adding them together. When I'm at minus 3, which is over here, right? We're going to do this. You're going to do this on the Jamboard in a minute. At minus 3, I have 2 different y values. I have this y value here, and I have that y value there. Those are the 2 different y values. The first y value is up here at 15, 16, 17. This is 18. The second y value down here looks like minus 7. All right, those are my 2 y values. So all I'm going to do is I'm going to add those 2 together. Right? Because that's what the function is asking me to do. I'm not changing the x, so I'm really just putting a new point along this same x equals minus 3 line based on the sum of the y's. So my minus 3 is still going to be my x value, but my y's are going to be whatever the sum of 18 and minus 7 is. 18 plus minus 7, of course, is 11. So I'm going to put that point in red right about here. And notice that that point is on the line, okay? It's on the line x equals minus 3, okay? All right, let's keep going now. Remember, we have to go from minus 3 to 5. So let's go to minus 2 now. So minus 2 on one line is right here at minus 5. On the other line, it's at 10. I'm just going to add those 2 points together, 10 and minus 5, which of course gives me 5. I'm going to stay along this line right here. And there comes my second point. Let me go over to the other side, right? Remember, I'm supposed to be going from minus 3 to 5, I think. Yeah, minus 3 to 5. So I'm going to put 1 point over on the other side. And then we're going to go over to the Jamboard. We're going to put all these points back in, and we're going to watch some people try to come up with the points themselves. Okay, so I'm going to put one more in. I'm going to go to the 5 on the other side now. So on this side over here at 5, my red line is at 10. My blue line, I should be putting that in black. I want to be consistent here. Okay, so my red line is at 10, and my blue line is at 9. Is that 9? Yeah, it looks like 9. So when I sum those together, I'm going to get 19. So here comes my next point, right here at 19. So what is this going to look like? What would you predict would be the shape of the function that, now that I've given you the third point, or one of the three of the 3 points, what would you predict would be the result of adding these two functions together? Any guesses as to what it's going to look? Well, I think you can guess it's not going to be linear. Okay, there is no straight line that I could join between those 3 points right now. Just not going to happen. What would you guess would be the shape of the result? I'm adding a quadratic function to a linear function. Any guesses as to what you might end up with? Quadratic? You're absolutely right. You're absolutely right, Sebastian. So I'm going to stop recording this. Okay. So we should all now be on the board, right? And what I'm going to do is I'm going to put in the first few points that we just talked about, right? And then I'm going to be asking one of you, I haven't spun my, in fact, let me go spin the wheel in the meantime and see who's the lucky person who's going to start us off on this. Excuse me. Let's see, who is this? Oh, okay. All right. I'll tell you who this is in just a minute. All right, I'm going to put the points back on that we just had before. Remember that we said, let me just move this up some more. We said that we would move it up a little bit more. Yeah, we would take corresponding values of x and add together their y. So the first one we took was minus 7 and 18. And when we put those two together, minus 7 and 18, we got 11. So here was our first point right here. Okay, everybody should hopefully be able to see that point. In fact, let me join the Jamboard myself on this other screen over here. Okay, so everybody can see that point at 11. Then I also did the same thing for minus 2. So minus 2 was at minus 5 and 10. Add those two together, you get 5. So that was my second point right there. And then my third point, I went all the way across to 5 and said, okay, I'm going to add together the 10 and the 9, which is going to give me 19. So that was my third point right there. Okay, so Ryan, I'm sure you're there. I'm going to ask you to put another point on the Jamboard. Any point you like. We have minus 1, we have 0, we have 1, 2, 3, and 4. Pick any point you like. You get to choose whichever point you want to put on. And I'm going to ask you to add that point to the board with us now, please. All right. I want to see you put that. Can't see the graph. You don't see the lines of the graph. I can only see the points. All right, I'll put that one in for you. Hopefully you're going to watch the video later on because that's important. I don't know why either. But you need to watch the video later on so that you can follow along with us. So you say, I'm saying that minus 1 is at 1 is what I'm going to put in here. That's my next point. All right, Ryan, thank you very much. Let's take you out for today. And let's get somebody else in on this now. So I'm going to be asking for any other point on this graph, and that task goes to Ella. Ella, you're up next. So maybe we could do this in stages. What is the y value? Okay, it's like you're ready to change it. Okay. Okay, now I agree with you. Well done. Well done. All right. Is everybody in agreement with that point that you just saw Ella put on there? Does that point make sense? Perfect. Okay. I'm going to go spin my wheel again. I'm taking Ella out for now. And we have quite a few more points left to go. And we also need to do subtraction as well, by the way. But let's just get through addition first. The next one goes to Brannon. Brannon, you are probably over there thinking, when is it going to be my turn? Well, now it is. So Brannon, oh, he's already there. Okay. Nice job, Brannon. Does everybody understand why his point is where you just saw that point go in? Everybody okay with that? Excellent. Okay. Brannon took no time with that at all. He was all over that. So let's take him out. And one of these days, I'll actually show you the wheel as it spins and picks who it's picking. The next one goes to Crisania. Crisania, it's your turn. We have what, 2 more points left that we can join, actually 3 more points left. And we can join them all together and see what this looks like. Crisania, it's over to you. Okay, so you're putting that point there. So you're adding together 1 and -2, and you're getting -1. Okay, wow. Some people are taking absolutely no time with this at all. Okay, Crisania is out for today. And next up, we have 2 more points left. So there's 2 and there's 4. Is Leanne. Leanne, are you back with us now? I know you took a short break. Are you back with us now? We can sort of get this moving here. Give me the y values that we need to put together for that. -2 and 2? No, 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 no. Let's try again. One of those isn't right. Okay. Uh, okay. So why don't we add those together then? Okay, good. So put that in the right place for me now, please, on the board. So I agree with you, right? You're saying it's at 2. So you're saying it's at 1 rather. So put that in on the board for me now, please, so we can go on. Okay, yeah, great. Thank you very much. So we have 1 more point left and 1 more person left to sort of put on center stage. And that goes to Alexander. Alexander, you're up next. Are you there, Alexander? Okay, somebody's hand is going up. Yes, Lynette, please go ahead. Sure. So Alexander's off to the races. The last point, remember what when I asked for the y values and Leanne said it was -2 and +3. Can you see that those are the y values at 2 when you look at both the red line and the blue line? Can you confirm that that's the case? The red at 2, when x is 2, what is the red line showing and what is the blue line showing? That's what we're asking. You see what I'm saying? Okay, so just add those 2 points together. Add those 2 y values together. And somebody is going ahead and drawing in, I don't know who this is anyway, and putting in the function and a little bit wavy, but you know what? That's probably no worse than what I would do. You know who I think that is? I can't tell. I think that is Quinn. If I'm not mistaken, that's probably, oh, is it Crisania? Is that Crisania? Is that you? Okay, all right. It is Crisania. Yeah, okay, good. All right, thank you very much. All right, now we have to try this again. I know we're running out of time. Getting a big up there. All right. We're running out of time and we only have about 15 minutes left, but we have to try a subtraction as well. So we're going to stick with the wheel and I'm going to move you all over now to board 2. Okay. And for board 2, so we noticed that for board 1, we got a quadratic. If I'm subtracting them, what would you predict I would get if I were to do that? So we're going to move over to board 2 now. And we're going to be subtracting. Oh, by the way, for board 2, right? If you go back to, let me just take you back to the smart board for a second here. If you go to the smart board, the second one is going to be f of x minus g of x going from -2 to 6. All right? Do you think it's a reciprocal, you think? Okay, we'll find out in a second. Well, that's an interesting observation that you're making there, Quinn. So f of x minus g of x, well, we're going to go from -2 to 6 this time. All right, so just bear that in mind, -2 to 6. All right, but we're taking, remember, f of x, the quadratic is the red line, and the linear is the blue line. So we're taking the red line, right? The f of x, which is the quadratic, the red line minus the blue line. Okay, so let me go back over to the Jamboard. So it's red minus blue. That's what we're doing here. Red minus blue. Remember that. So everybody should now be on the Jamboard, right? Red minus blue. Let me just say that again. Red minus blue. Okay, let me go over here. See if we can get at least a few points on this. Alexander is out. And the next, I don't want to say victim. That would be cruel. The next hero is Hunayn. Okay, that's who we're going to be talking on next. So Hunayn, are you ready to go, sir? Can you try one of the points, please? Okay, Sandra, you know what? Since you're volunteering, I'll let you go after this. But Hunayn is next, all right? So Hunayn, pick any of the points you like. We're going to go from -2 to 6, though. Actually, you know what? Let's go from -2 to 5, because I don't think we have enough space for -2 to 6. Let's go from -2 to 5. Excuse me. For any point you like, you get to pick whichever point you like. Put any point you like on there from -2. Remember, it's the red minus the blue. I want to just stress that. So it's the f of x, which is the red, minus the g of x, which is the blue. So you pick any point you like and put that on for me, please. Starting anywhere from -2 up to 5. So -2 is the first one, 5 is the last one. Pick any point you like, go for it. You want to go with -2. Okay. Let's find out, looking at the Jamboard. You're on the Jamboard, right, Hunayn? Yes, you're on the Jamboard. Can I ask you to circle on the Jamboard the two y values at -2? Just circle it for now, please. Just circle them. And then we're going to talk about what we're going to do with those points, right? Circle them, please. Over to you. Just put a circle around it. And the other one at where it is at on the other graph, put a circle around that. Okay. Now, what are those y values? Give me those two y values. You can write them in the chat if you like. What are those two y values? Read them off on the y-axis, please, Hunayn. You understand what I'm asking you? You circle 2 points. They have y coordinates, so -5 and 10. Now, the order matters this time. So we're not just adding them together, we're subtracting them. It is the red line minus the blue line. So when you take the red line coordinate and minus the blue line coordinate, what's the result of that? Right on the Jamboard right now and ask you to do this calculation. So it's this minus this. That's what I'm asking you to do, Hunayn. The result of that is certainly not 5, as I'm sure you know. You're minusing a negative. No, you're not. You just got to think this thing through carefully. So what's the answer now? 15. Put that on the board for me now, please. Put it in the right place on the board for -2. And everybody else, just be patient. All right, we'll get through this. We just have to make sure everybody else is on board with this. Thank you very much, sir. At -2. Okay. All right, Sinduja, you were anxious to get on with this. So let's see you put the next point on. And hopefully it's right. I mean, you volunteered, so it better be right. Okay. All right. No, you don't have to apologize. You just need to let us know when you need the help and we'll give you that help. All right. So you're thinking that this one here is at 5-1, you say. Right? What does everybody else think about that? Natasha and Chrisania, and it looks like you got a lot of people on your on agreeing with you on that one. Because what you're doing, you're taking 10 minus 9. You're absolutely right. Good job. All right. So Sinduja has jumped because she wanted to make sure that if I call on her, she could get that. She'd be okay. So she chose, you know what, that's a good strategy. Anyway, let's see if we can get a few of these out rapid fire here. It's like Lance. Lance, are you there? Where is Lance? Lance, perfect. Okay, Lance, put a point on the graph for us, please. Any point you like. Oh, by the way, let me just erase this here, get this out of the way. Okay, so Lance is like fast out of the gate, but is he right? Let's see if he's right. What do other people think about that point? Let's check that. So we're looking at taking 4. Okay, how does everybody else feel about that? Natasha says, good job. Okay. Edwin says, yes. Okay. All right. You know what? We're just going to move on. Thank you very much, sir. You're minusing. Just don't forget you're minusing. All right. Let's see if we can get a few more in quickly. And there's one more thing. Well, actually, quite a few more things we need to get through this. So we'll have to squeeze a lot into tomorrow's class. All right. This looks like we're going to go to Shiabon. Shiabon, it's your time. Shiabon, are you there? And are you ready for us? Thomas, are you back with us now? You were called on before. We couldn't find you. Thomas, where are you? Okay, Shiabon, we'll get to Thomas first thing tomorrow. Anyway, Shiabon, can you put another point on the graph for us, please, very quickly? Okay, Thomas, yes, good. We were calling for you just now. We couldn't find you. We're going to get Shibon to do this, but I may start off tomorrow's class with you at the helm, okay? But back to Shibon. Shibon, you ready to put out another point? Oh, you already put one on in there? Let's see, let's see. So that would be 0 minus. Okay. You're putting, that's you at 0 there, Shiabon? Is that your point that you just put on there? Done? Okay, yes, I agree with that one. Okay, very quickly. Thomas, you're now here. Can you put another point on our grid for us, please? Instead of set up tomorrow, let's just see if we can get it in there quickly for today. All right. I agree with your point, by the way, Shiabon. Thomas, if you need some help, let me know, but it's over to you. We're asking to put a point on the graph, just any other point very quickly at either 1, 2, 3, or 4. Any other point need help? Okay. So pick a point between 1, 2, 3, or 4. We'll just put that one on and then I think we'll have to stop after that. Pick a point between 1, 2, 3, or 4. We're going to walk you through this. Which point do you want to go with? Okay, so you want to go with 4. Okay. I want you to circle on the graph the point on the graph on the red line when x is equal to 4. So go to that point on the graph where the graph, and do the same thing for the, perfect, do the same thing for the blue line for me now, please. Circle the point at 4. Okay. Now, write in the chat what those two numbers are. Give me the red line first, the red line y value first, followed by the blue line. We're going to be subtracting them. So you're saying the red line is 4. Good. What is the blue line? What is the blue line? Give me the point. You circle it on the graph. What's the blue line? 7. I want you to take the first number and minus the second number. What is the result of that? No. I want you to take the first number that you wrote in the chat for the y value and subtract the second number that you wrote in there for y. You told me 4 and you told me 7. I want you to subtract those two numbers from each other. What is that? Okay, so put that point in for me, please. On the graph. You can put that point in on the graph for us, please. And of course, unfortunately, we're going to have to wrap it up after that. So that's the coordinate you're giving me. Wait, need to add one. Okay. All right. Okay. All right. So very quickly, you know what? Anybody, just quickly put all the anybody who could just quickly put all the points in. We can just quickly draw a line in, and then tomorrow we'll talk about this some more. Put all the points in. Anybody can just put us some points in for us, please. How about 1 and 2? Quickly. What are the points of 1 and 2? Okay, I like everybody working at once. I like that. Cooperation. Cooperation. Okay, somebody, one of you artists, draw the line in for me now, please. Clearly, this one is also quadratic. And tomorrow we'll talk about what happens if it was the other way, right? If you were subtracting it the other way. All right, so quickly draw that line. Oh, look at that. Everybody is like, um, I love the Jamboard. Okay, and somebody's gonna write something, really congratulatory for everybody there. Okay, thank you very much, folks. We'll leave it there. Yeah, we'll leave it there. Join me in block 4, please. Tomorrow we'll finish up the stuff on addition and subtraction. All right. See you in block 4. Bye now.